But Steve, go ahead. Thanks.
Great. Um, so as was mentioned, Festo is a very large automation company, but we spend a lot of our R&D efforts on trying to mimic nature because nature is so efficient in what they do. And a lot of that has been focused on soft and adaptive gripping, which is a important part of agricultural automation. So shown there, our elephant trunk and adaptive gripper. And we don't just do this for marketing purposes. One of the things that came out of this was actually a real product. So being able to have adaptive fingers that are built on the bone structure of a fish as a real product that people can use to be able to pick up delicate things. We've gone now and developed a Chameleon Gripper tongue that does similar things. And so where is all this is going is trying to get to a better place within the agriculture space for being able to do some of the gripping and physical touching methods of picking up various fruits and vegetables that currently aren't possible or are difficult. And I'll show a quick video of our latest endeavor, which is actually trying to mimic a human hand, which is arguably the best gripper on the planet. But there's a lot of complexity that went into this. So this is actually all pneumatically controlled, and some piezo valves are mounted in the arm, being able to control everything, and we can articulate the index finger, we can articulate the thumb, and really get it to do a lot of the things that a human hand can do. But it's more than just the movement, it's also the sensor. So, having that tactile force feedback. And so there's actually 113 sensors in this thing designed to be able to grab everything. And the reason I'm going in depth about this is that this is very complex, which makes it generally more expensive, right? And so that's one of the reasons that we haven't seen advancement within that. Another big thing too has been there really hasn't been a lot of need in the market, I would say up until the last 5, maybe 10 years. And a lot of that has to do with vision not being at all caught up with where physical needs are. So you didn't have that ability to scan, an apple orchard and know what apples were good or bad. That just wasn't there, or if it was in the R&D stages. It wasn't really into startups. And so now vision has really exceeded what we can do from a mechanical standpoint, or can do cost effectively from a mechanical standpoint. And so there are quite a few challenges in robotics and end effectors in and how to deal with all that. And kind of using our soft hand as an example, starting with vision, I wouldn't say it's solved, but it's gone a long way. There's still challenges with various types of organic matter are still very difficult to sense. And then you have the data sets, some of the things that we just talked about in the last session of, getting all these different data sets to be able to do this can itself be a challenge. Then even once you can see what you want to get, you have to actually go get it. And so avoiding various structures, and you can do that with a 6-axis robot as an example, but then you're adding a bunch of costs in because every axis is another point. And then you have to have pretty intelligent systems to be able to articulate around different things to be able to get to those things. Something we can obviously do, but it is complicated and potentially expensive. And then you have people, right? So, we can do a whole session on collaborative robots sometime, but, like what is about safety and what's good interaction, what's bad interaction. Local machine safety laws turns out to be a pretty important thing as well, of what is legal to do where. And then, being on the farm, you're putting a robot potentially in the hands of a farmer who's probably not trained on robots. And so how do you either educate them to do these things or make your system autonomous enough to not need those things? And then you have adaptability, right? So this gripper that we made, potentially you could do a ton of stuff with it, but that makes it more expensive and potentially a lot more capable than needed for a given task. But if you want to focus on a single task, then you're spending a lot of R&D efforts to really focus on that one individual thing. So it's a balancing act with that, and especially with cost. And then the agriculture environment throws a whole host of additional challenges on there. because in addition to being smart and good sensors and very advanced, now I also have to be resistant to dirt, resistant to water, UV resistance, weather resistance. It needs to be rugged. It needs to be able to, take the abuse of a farmer or a tractor or a farm animal potentially. Food safety is a big deal, so now we're limiting the scope of what materials can be acceptable for a component, again, driving costs up potentially. And all that, I'm still trying to make it low cost and makes it difficult, and then soft. And that soft part isn't required for everything, but for a lot of things it is, and that becomes a pretty difficult thing to do as well. So that's the end of my intro. If you want to check us out on YouTube, show your kids. It's a fun little site. We got a whole zoo now. So I'll stop sharing.
Thanks, Steve. Yeah, can you leave that last slide up? That's such a great slide. Sure. Yeah. And so, and this is nice. I think a lot of people, especially in the general public, know Festo as doing amazing biologically inspired robotics, which you can see, like, for instance, the kangaroo, butterfly, many other projects here. And I think people, the layperson may know a little bit less about what kinds of technologies are being used by industry today. And so I was wondering if you could help us sort that out a little bit. What kinds of gripper technologies, for instance, are being used in factory settings right now? And are some of these examples used, for instance, like the chameleon tongue gripper, are they being adapted? And if so, or if not, like, what are some of the challenges to that specific real world applications?
It's like where the chameleon tongue is being used now, I think, is a lot for, think about like the Amazons, the Walmarts, the big warehouses where you're going to have to pick something random out of a box and be able to do it effectively. That's where there's a ton of interest in that. I'm curious to see how much that'll extend to like the Blue Aprons of the world, where you're assembling food products, and how customized that can be. But really, for the most part, we're still seeing, standard, just open and close grippers largely being used. And most of these food applications still have not adapted to food gripping because of the challenges. It's slippery, it's softer, and then you got to clean it. And there have been some companies that have brought out some technologies, and it's both having the end effector capable, but then your axis itself also needs to be able to withstand that environment. So you don't see, too many companies with IP69K wash down collaborative robots. I mean, that's just not something that really exists. And so because of that, there hasn't been that need for that end effector development either.
Okay. Thanks. No, that's really fascinating. So here's a question from Andra. Steve, what do you think about having thermal scissors for picking instead of imitating a human hand?
I'm curious to learn more. I don't know enough. I don't know what a thermal scissor is, but
like a cutting hot wire. Andrew, do you want to chime in there?
Oh, I would suggest Kitten Shende posted that into the Q&A, and I just translated it. Oh, so okay. Hopefully I'll give him ability to talk and we can come back to that. But in the meantime, oh yes, he has repeated the question again. Just hold tight a second and I'll empower you with speech. It keeps bouncing. Someone might have given you the ability to talk now. Yes. Ketan?
Hello. Thank you so much, Andrea.
Can you explain thermal scissors, please?
Yeah, sure. So Steven, thermal scissors, I mean, I've read this concept where, instead of imitating a human hand or having something to pick physically, we can have, for example, if we want to harvest tomatoes, there's a small stem which comes out from the tomatoes. So instead of just grabbing them and just picking them up, we can use thermal scissors to, gently cut the stem, and so that the fruit is not, destroyed, or even there's no harm to the entire plant. That's what I mean by thermal scissors.
Okay, yeah, that's That's a viable way that a lot of companies have approached this, has been to try to get, behind the fruit to cut the stem. I'm sure there's some products that are much easier to do than others. Either way, if you do cut it, you have to catch it somehow. And that's not to say that a human hand grabbing an apple is the best way to do it. It might be with the thermal scissors or a similar thing, but the general need has been expressed quite often of, I still want to be able to pick this up even after I get it into the bin. Maybe I want to be able to sort my apples on a conveyor and grab the ones that I want. There's other methods of doing that, of course, but soft gripping has still been a pretty interesting technology to see where the market has driven the needs or hasn't in some cases.
All right, sure. Thank you so much, Stephen.
There you go.
Thank you so much, Andrea.
So it's interesting, though. It seems that soft gripping may have a couple of different applications. So if you consider the chameleon tongue a soft gripper, it's used for its versatility. But maybe more interesting to the food space would be its ability to not damage soft fruits, such as, there's a very, very wide range of soft fruits that we would like to be able to harvest robotically. Strawberries being a very popular one right now, but any of the berries, peaches, nectarines, tomatoes for human consumption. Steve, do you see there opportunities in the near future to develop grippers that can handle those kinds of things?
Oh, absolutely. I mean, it's a very dynamic market right now. We'll put it that way. The needs are being expressed, but I wouldn't say concretely enough that we can define exactly what the market needs on a broad scope. And so it's very project oriented right now. And so, as we engage with various startups, you develop a solution and you hope that they succeed in market, because then we can produce that. But if they don't succeed with it, it's just an idea right now.